This conference will now be recorded.
Very good evening, students. Welcome to the PYQ discussions on JEE Main paper 2024. Today we are going to discuss the question paper from the 6th of April, SIP 2, JEE Main 2024. Let us start our discussions. So this very first question says that there are two fixed charged spheres PQ repelling each other with a force of 16 Newton. A third neutral sphere is placed between charged spheres. The new force between the spheres is that's how much? Assuming all spheres are insulating. Suppose there are two spheres initially. Okay, the force of repulsion between them is 16 Newton. Okay, force of repulsion. Now a third neutral sphere is placed between the charged sphere. Okay, suppose this is third one, this is second, and this is first one. Now see the spheres are all insulating. That means no one can lose or gain any charge from outside. Okay, now this sphere is neutral, and since it is neutral, so it will not have any charge, so Q will be 0. Since all the spheres are insulating, so they are not, see, this first and second spheres are not contributing any charge to this guy, this third one. So therefore the system is like that. So there are two spheres, first and second, which are charged, and third one is neutral, that does not have any charge. So if I have any charge, like anything uncharged or unaffected by these two charges, so this is the case, like there is a medium in between the first and second spheres, but this medium is unaffected by the spheres or the charge of the spheres. So therefore there is no modification in the repelling force between the first and second spheres. Therefore the new force between the spheres is remaining the same, that is 16 Newton. Okay, all right, let us go to the next problem. So this question says a tree branch holds a weight of 200 Newton by a uniform chain of mass 10 kg. The force applied by the branch to hold this weight is dash. See, sometime we what we do, we just suppose this is kind of a tree, so these are the branch. Suppose I have a suitable branch to hang some weight. Okay, suppose this is a tree and the branch is, I think this is too sophisticated, let me draw the natural one. So suppose this is a kind of branch. Okay, so okay, look like branch of a tree, like, okay. So anyway, So let us take this as a banyan tree. So there is a branch, and see there is a chain like this, okay, and there is weight given to it like this, okay. So this weight is hooked with the chain. See, this chain is actually attached to this branch like this, okay. Let me just, yeah, so this is the thing. So this is giving downward force. So what 200 Newton means, it is giving 200 Newton downward force. And see, the chain is uniform and it has mass of 10 kg. So it has mass 10 kg, right? So this chain also will give some force in the downward direction due to its weight, right? And how much is that? That will be 100 Newton, okay, due to chain, due to chain. See, to hold this weight, the branch has to apply force of this total, right? Like it will be holding if the force applied by the branch is how much? 200 plus 100 Newton. So total 300 Newton force is applied by the branch to hold this weight, okay. So this will be 300 Newton. Let us go to the next problem. Okay, so this problem is saying that if kinetic energy of a block of mass m becomes 36 times by keeping its mass constant, by what percentage will the momentum increase? See, the question is saying that, say this is a block of mass, okay, and it is given certain momentum such that without changing the mass, we are giving certain momentum such that the kinetic energy, suppose earlier it was k1, now after giving certain momentum, the kinetic energy is becoming k2, and k2 is actually 36 times k1. Okay, this is actually the kinetic energy now after changing, or see, mass is remaining fixed, okay, mass is kept fixed, only the momentum is increasing. That is why the kinetic energy has increased up to 36 times of the previous value, okay. Let me tell you the relation between kinetic energy and linear momentum that you know very well, that is p square by 2m, right? So what I can write for this two guys, let me write with this. Suppose I write k2 by k1, then it is p2 square by 2m. M is not changing, so let the m be the same, and this is 2m divided by p1 square. So these two cancels each other, so I get p2 by p1 whole square, and this is k2 by k1, and k2 is actually 36 k1. So I can write this p2 by p1 whole square equal to 36, and from there I can write p2 by p1 is equal to 6, or p2 is equal to 6p1. Now what is the change, percentage change? I have to see the percentage increase in the momentum. So I have space here. Okay, so let us see, the initial momentum was p1 and the final momentum is P2, which is actually 6P1. Now percentage change, I have to find out percentage change or percentage increase. So in that case, I have to do this PF minus PI divided by PI into 100 to get the percentage increase in the linear momentum. So I have 6P1 now. Earlier it was P1 divided by P1 into 100. So what I get from here? I get 5 from the numerator, and P1 cancel each other. So this will be 500. This is in percentage. So 500%. So what is the increase? Like what percentage increase in momentum we will get in this case? That is 500%. And look, this is the answer. Option D will be the answer for this question. Okay. Now this is very interesting problem. Let us try to understand and solve it. What is the question saying? What is the question saying? The question is saying that a ball is projected vertically upwards from a building. Suppose I have a building here. Just a minute. Yeah. Okay. I have a building over here. Okay. So from here, a ball is projected upward, vertically upward from here. Okay. So what is this? This is actually projected in this way. Okay. And the time taken to reach the ground is T1. So it goes up to some height and then come to ground, right? All right. So the time taken by this is T1 to reach the ground. Now another ball is projected downward with the same from the same building with the same speed. Look, another ball from the same building. Suppose this was projected with u velocity. Now it is projected in the downward direction with the same velocity u, and see it reaches to the ground. Okay, it reaches to the ground. Okay, let me just change the drawing a little bit here. Okay, let us take this as ground. Okay, the second ball, which was projected vertically downward in the downward direction with the same speed, is reaching to the ground in time t2. Okay, the time taken to reach the ground is t2. If the third ball is just released from the same building, the time taken to reach the ground. So now a third ball is just released. Release means there is free fall. Okay, there is a free fall here. So this is free fall. Release means no initial velocity is provided. Okay, free fall, you can say this is free fall. Okay, so if the time t3 is taken by this ball to reach the ground, what is the value of t3? You have to find out, and these are the options. You see, this t3 can be found out in terms of t1 and t2 like this. Just a minute. Okay, so this is the question. I hope you have understood this question. Now let us try to solve it. So how to solve this problem? Okay, so for the first case, you look, if we write, see, I have to, first of all, I have to find out what is the height of this. Okay, let me take this height as h. Okay, let us take this height as h. Okay, So if I know the height, then T3, see, I can write easily half G T3 square. Okay. See, from here I can actually find out 2 2h by z, 2h by z, square root of 2h by z. So what is the agenda? My agenda is to find out what is this height from the given informations for the previous two balls. Okay, in terms of T1 and T2, I have to find out h. So that is the main point here. So once we are able to find out h, then the question is solved. Okay, let me go to the next page. Okay, so let me tell you, see, I have the ball here. First ball, I'm just giving an upward velocity, but the height I'm actually measuring in this direction. All right, so let me take this height to be minus h. Okay, and the upward direction to be positive, so this velocity is positive. But again, g is acting in the downward direction, so g is minus. So for the first ball, what I can write minus h is equal to minus u t1 minus half, sorry, this will be positive, half minus half g t1 square. So this is from the kinematic equations. S is equal to ut plus half at square. Here a is minus g, u is here u itself. Okay, initial velocity in the upward direction, and h I'm measuring from top to bottom, so that's why it is negative. Now for the second ball, it is just given a velocity in the downward direction, so this is negative. G is again negative. Okay, so what it will be? It will be minus h minus u t1, same velocity, right? So that's why minus, sorry, this is not t1, t2. The time taken by the second ball is t2, so this is minus half g t2 square. All right, now see what I can do. I can rewrite these equations like, see, ut1 is equal to minus h plus half g u1 square, and from here I can write down, I'll take this to this side, so u t2, and this is h minus half g t2 square. Okay, I hope this is all right for you. Now see, if I give the name to these equations 1 and 2, then let me take the ratio of this. So I'm just dividing equation 1 with equation 2. Let us see what we get. We are getting t1 by t2, okay, is equal to c minus h plus half g t1 square divided by plus h minus half g t2 square. This looks like a little bit complicated, but anyway, we are trying to solve it. So I have to find out what is h, right? So see, this is ht1. Let me multiply both sides. Minus, sorry, ht1, then half g t1 t2 square. This side it is minus h t2 plus half g t1 square t2, right? Now let us take this to together. So I have T1 plus T2 like this, and if I take this to other side, so half G, let us take this common, and let us take T1 T2 common. T1 T2 common, so from here there will be T1 here, and this will be positive on the other side, and from here I'll get T2. Look guys, this T1 plus T2, this T1 plus T2 I can cancel out. So what I get is, I get as half G T1 and T2. So this is my turning point. So once I get half G T1 T2, let me come here and see, I had given you this formula, right? So I have to find out T3, the time taken by the third one to reach the ground will be 2h divided by G. So what I have got as h, look, h I have got half G T1 T2. Okay, so 2 by G, let this be here, then I get G T1 T2 by 2. These two cancel each other, these G cancel each other, then we get T1 into T2. Okay, square root of T1 into T2, and hence the first question, first answer, okay, first option will be the answer for this question. Okay, so guys, it was really very easy, but you have to get the right clue at the right point. Okay, then only you'll be able to find out the answer. So option A will be the right answer for this question. Okay, so let us go to the next problem. Yeah, so the weight of an object is measured on the earth's surface 300 Newton. What will be the weight of the same object at depth? It says depth inside the earth. So what is the relation at depth? Okay, so if you remember, G is equal to G into R square divided by R minus H whole square, right? So now let us see what we are getting here. This is G prime, G depth at depth. Okay, let me take this H as D here. This is the formula, right? So G into R square divided by R square, so R minus R by 4, see R by 4 whole square. So what I get, I'll get, see this is 4, so 3 R, that means 9 R square by 16, right? So further G, see this R square I can cancel out, so it is actually 16 G by 9. Now let us put this value. So it was actually 300 Newton, right? 300 Newton. So 300 Newton means mg. Okay, so m will be 300 Newton by g. Okay, so this is the on the surface. Now I have to find out what is the weight w prime is equal to m into g prime. So m is 300 by g into g prime is g into 16 divided by g into 16 divided by 9. Okay, this cancel each other. Excuse me. So now 100, this is 3. Okay, so what we are going to get here? I think we have done some mistake. Let me check. 300 Newton on the surface. Did I write the right formula? The weight of an object measured on the Earth's surface is 300 Newton. The weight of an object measured on the Earth's surface is 300 Newton. What will be the weight of the same object at the depth? Let me just check once again whether. Okay, so depth means what is the formula for the G at the depth? We have to cross check if the formula is all right. So at depth, how G varies? Okay, I think I had written little bit wrong here. So G prime will be G into 1 minus D by R. Okay, so this was the real thing. Or you can write in terms of this. So the one I had written is actually for height. Okay, all right, so this is the depth. Okay, this is the real formula for the depth. I'm sorry for that. Okay, let me just then do this. G 1 minus D is R by 4 and divided by R. So this will give you G into 3 by 4. Okay, G into 3 by 4. R will cancel each other. So now it is all right. See, now if I want to find out mg prime, so mg into 3 by 4, mg is given on the surface, that is 300 Newton, divided by, sorry, into 3 by 4. So this is actually this one, and this will be, okay, so this much Newton. So option B will be the right answer for this question. Okay, so I apologize for the wrong formula. Okay, so that was actually for, so this is for height, guys, you should remember this. This is actually for height, r square by r minus h whole square. Okay, this is for height. Okay, and for the depth it is the formula. Okay, all right, don't get confused. So this is just simple formula putting problem, nothing else. All right, so let us go to the next problem. This problem says an isolated system contains 1 mole of helium gas, helium. Okay, given a heat of this much, heat is given. The temperature of the system changes by 2 degrees centigrade. Find the work done. Okay, we have to find out the work done when the temperature changes happens by 2 degrees centigrade. Okay, Let us see how we can solve this problem. We know first law of thermodynamics, dq is equal to du plus dw. Okay, dw means work done. So we have to find out what is work done. So dq minus, let us write this as delta also, delta u. Okay. So what is this delta u? For an isolated system, we have to find out what is this delta u. Okay, how to find out that? Helium gas. Okay. So helium gas, so I have to find out change in the internal energy when the temperature change is given. Okay. So in this case, we have to actually use the degrees of freedom and average energy, and then you have to get the internal energy. How much we know internal energy? Change in the internal energy. Okay, let me write this. Internal energy is half into RT for 1 mole into degrees of freedom. Degrees of freedom. Okay. This is actually internal energy. So how do you get this degrees of freedom? So helium actually is monoatomic gas. Okay. Helium is monoatomic gas. So for monoatomic gas, what is the degrees of freedom? That is 3. So I can write 3/2 R, and here I'm finding out change in the internal energy. See, let me first write this is 3/2 RT. F is 3 here, 3/2 RT, and change in this internal energy will be 3/2 R into delta T. So this delta T is given as how much? 2 degree centigrade. Okay, 2 degrees centigrade. So this R is actually in mole Kelvin. So per mole Kelvin. Okay, per mole Kelvin. So better to have, okay, delta Q is given 48 minus 3/2 R into delta T, that is change in temperature. Okay, so here change in temperature is 2. Okay, change in temperature is 2. So if we do this, look, the value of R is given, so 3 into 8.35. Okay, I'm sorry, there is some. Just a minute. For 1 mole, it is fine, half RT into F into delta T is also fine. Okay, guys, I'll just come back with this in the next class. Okay, because I'm getting the value none of these options. Okay, so I'll just come back and clear this doubt in the next class. Let us solve this problem. This problem says an ammeter consisting of 240 ohm galvanometer, that means RG is given, and 10 ohm shunt S is given, 10 ohm, connected in the circuit as shown in the figure. Okay, so this is the circuit. Reading of ammeter, you have to find out what is the value of this. Okay, that means I have a galvanometer. To make this galvanometer or turn a galvanometer into ammeter, I have been given a shunt. Okay, shunt is connected in this way. This is RG, right? And this is S. So what will be the reading in the ammeter? So you have to find out what is the main current in this. Okay, so from here I can find out. See, 140 is the resistance, 44. 24 by this will be the current here. Okay, so 24 divided by 140.4. Okay, around some 0.17. This is the current, the main current. Okay, you have to find out what is the current in the ammeter. Okay, this is my galvanometer. So this is actually the range given. Okay, this is the range. The galvanometer current is not given anyway. Most of the current will pass through this. Only few ampere current will pass through this. Okay, so let us take this voltage over here. If we just have this much, okay, I know IG RG is equal to ISRS. Okay, this will be 24 if, but IG is not given. Okay, let me just find out this equivalent resistance. Okay, so what is the equivalent resistance over here? This is 240 divided by 25. So that gives actually 9.4, 9.6. Okay, 9.6. If I add to this, okay, let me add 9.6. So what I get? So I get 150 overall. So if I get this total resistance of this as 150, so 24 by 150, let us see how much we get for this. Okay, so 24 divided by 150. Okay, so this will be actually answer, that is 0.16. All right, so option B will be the right answer. Look what I have done. I'll just tell you now. See, I have to see how much is the resistance of the ammeter. So resistance of the ammeter is given in this way. Look, so I have the galvanometer. I have converted that into an ammeter. So galvanometer has 240 ohm resistance, but now this has been converted into ammeter by shunting this RG with S. So what is the resistance of ammeter? That I have found out. Resistance of ammeter. Okay, so that much resistance. So how do you find out? From this combination. Okay, this is 240 and this is 10 ohm. So parallel combination of these two will give you how much? This much. Okay, so how much? This is 9.6 ohm. So that will be added to the circuit if you connect the ammeter in series. Now you have got total resistance in the circuit and the voltage is given anyway. So that will give you the answer for this question. Okay, so ammeter will show 0.16 ohm, sorry, ampere, 0.16 ampere current. Okay, now let us go to the next problem. Okay, so this problem is saying that a convex lens has a focal length 20 centimeter, R1, R2 are given. The refractive index of the lens is x by 2. The value of x is how much? So when no medium is set, see, this question can be solved from lens maker's formula. Okay, lens maker's formula, using lens maker's formula. Okay, actually you might get so much of noise of thunders and also rain because it is heavily raining here and there is thunderstorm going on, but still I am continuing the class. So as long as my power is permitting me with the laptop, because there is power cut also. Okay, so I'm going with mobile data since I have data today. I'll continue until it is not getting over. And also I think I have few more questions to discuss, then we'll stop. So I mean, if my laptop is getting off, madam, you can just switch off the recording, because I may not understand when my laptop will be shut down because of lack of power. And one more point is my data is also limited with the mobile. If I'm out, then please switch off the recording and cancel the meeting. Okay, all right. So a convex lens has focal length this much. So lens focus formula we know, right? So 1 over f is equal to mu minus 1. I am taking the medium as the air, and this is 1 by r1 minus 1 by r2. Okay, so r2 generally we take as minus 30 centimeter given here, and r1 is given as 20 centimeter. Okay, and 1 by f is also given, so I can write 1 by 20 into mu minus 1 whole into 1 over 20 minus of minus, that means 1 over 30 with a plus sign over here. So what I get, mu minus 1 whole into, this will be 60, I guess. Yeah, 60. This is 3 plus 2. Okay, by 60. So I can write for this as 1 over 12. Okay, for this I can write 1 over 12. Okay, so what I get, mu minus 1 is equal to 12 by 20. So it is 4 3s and this is 5, and mu is equal to 3 minus 5 minus 1. So I think, oh, this will be positive. So this is 8 by 5. Somehow I'm getting this. Okay, let me just check with this whether I have written fine. Yeah, it was all right. So 3 2 5, so 1 over 12, this is fine. This is centimeter, all a centimeter, fine. I see this is 15. I'm sorry, this is 15, so that's why I'm in the trouble. Okay, this is, then this will be different. Let me cross check. Okay, this was 15, guys, I'm sorry. So otherwise things are all done. I think I'll be able to finish this and then my laptop will shut down by itself. So this is 2 plus 1 3 by 30, so this will be 1 over 3, sorry, 1 over 10. So 1 over 10 into this, I'm sorry, I'm doing too fast. 1 over 10 with this, so mu minus 1 will be 10 by 20, this is half. Okay, so mu will be half plus 1, this is 3 by 2. Okay, 1.5. So this will be actually 1.5. Okay, I'm sorry, 3 by 2, that means, you know, x, the value of x I have to find out. So value of x will be actually 3, x by 2, right? This is fine. Okay, let us try to solve this. If things are okay, we'll be able to solve it. Okay, for a device, power consumed is this. Okay, power is this, and voltage supply is 220 volt. Number of electron flows is 1. Okay, in 1, I think it is in 1 second, is this much, x by 4 into this. Okay, so that means, you know, you have to find out what is the current first of all. Okay, let us find out. So P is equal to VI. So P by V will be actually the current 1 on 10 divided by 220. So this is actually current flowing in 1 second, or charge flowing in 1 second. So how many? So this one is the charge in 1 second. Okay. So we know, if we, so NE is total Q. Okay, N into E is total Q. This is in 1 second divided by 1 second. So this is actually becoming 1 second, means this is the current. So I have to find out what is N. N means I have to multiply, sorry, 110 divided by 220 divided by 1.6 into 10 to the power minus 19. Okay, this is the thing. So look, this is 2. Okay, sorry, this is 1 over 2. 1 over 2. So this will be 10 to the power 18 divided by 32 somehow. Okay, so x by 4. And 10, okay, so I have to make it 10 to the power 7. So let me just do this here. So 10 divided by 32 into 10 to the power 17. Okay, so this I have to make, see, x by 4 is equal to 10 by 32, right? This is 8. Somehow it's going towards the fraction, I don't know. Okay, let me do once again. This I have to make, okay, 5 by 4. Okay, so x is actually, oh, x is 5 by 4. How is it possible? What? This is voltage in 1 second or 1 minute. Okay, let me just check once again the question itself. Just 1 minute, guys. I'll just check the question once again. For a device, power consumed equal to 110 watt and voltage supplied is 220 volt. Yes, this is fine. This is in 1 second. X by 4 into 10 to the power this. Okay, let me just clean everything and try to do it again. So guys, this is actually P is equal to VI that we have already found out. So P by V, that means 110 divided by 220. So this is actually 1 over 2. So this is in ampere. So 0.5 ampere. This is all right. Then number of electrons I have to find out. So this is in 1 second number of charge. So N into E by 1 second is the current, which is 0.5 ampere over here. So I have to find out what is the M. That means 0.5 divided by 1.6 into 10 to the power minus 19. Okay. So this should give you, see 5, this I can cancel out. So over this 10 to the power minus 19, that means 500 divided by 16 into 10 to the power minus 17. Let me make this 4. Let me divide this 500 with 4. So how much I get? So I'll get 125. 125 divided by 4. Okay. So yeah, somewhere I was doing some calculation mistake. So x by 4 is this. So x is 124, guys. Okay. All right. So this is the answer. I think I'll better stop it here. In the next session, we'll take up the remaining questions. So thank you for your patience. Bye for today.